Hello, my name is Adam Deary. Today I'm talking about psychological factors. Psychological factor data include smell, light, sound, taste, texture, and temperature. These are significant parts of ergonomics and human efficiency and can be affected by all these factors that I said. Methods of collecting data include four types. First one being ordinal, which is defined as being labels used in labels such as words, symbols, letters, or numerals. When numerals are used, they indicate sequence of order. For example, ranking someone in a competition as first place, second place, third place, rather than giving them a specific score. And this can be gathered through percentage or some other type of data. So I have two examples of this. I have example A, which is um, these here. Ones show all different types. So we have, for example, asking about gender. We have someone asking about um, color, race. We have some basic data. So point is that ordinal data, you can derive a percentage. Um, so you could say which one's first, which one's second. You don't necessarily get a score, but you get a percentage, and so on and so forth. Um, Same goes here. This is talking about data from 1 to 5. So maybe graph a bell curve of what's the average, how people felt that day. Um, Here we have the same deal. Um, this has application in business. For example, survey given by a company after you do their service, so they can find out what was the most said response after as a reaction to their service. I another example is interval scale is a more powerful scale, as intervals or difference between the points or units are of an equal size. For example, in a temperature scale, measurements are using an interval scale that can be subjected to numerical or quantitative analysis. So for example, here I have these two examples. Sorry, one example, I have a degree Celsius temperature monitor. So for example, it will tell you depth quantitative data for between degree tell you. So this digital is accurate and has a lot of applications. Next, I'll be discussing ratio scale. The difference between a ratio scale and an interval scale is that the 0 point of an interval scale is some arbitrarily agreed value, whereas on a ratio scale it is truly zero. For example, 0 Celsius has been defined arbitrarily as the freezing temperature of water, whereas 0 grams is a true zero, but it has no mass. So the difference is that interval scale has a clearly defined arbitrarily agreed value, whereas a ratio scale is not really. It's just a system of in which a system of a frame of reference where 0 grams doesn't really exist, but we use it as a stepping stone to measure and compare other pieces of data. That's why it's called a ratio scale. So example would be you have a scale like a weight scale. This is a ratio scale. It starts from 0 grams, but it's not really possible to be 0 grams. But the way it's designed is the system can measure from zero up presumably to 160 or to a certain limit, and this gives you the same quantitative data that an interval scale will give you. However, as I said, the the arbitrarily the arbitrary value of 0 grams is not widely agreed upon. So briefly, I want to talk about qualitative versus quantitative data. So um, you have ordinal, which is qualitative. So For example, as I said, taste, smell, texture, and then we have interval data, which is sound, temperature, weight, light. Quantitative data may be used in a design context relating to psychological factors, but individuals vary in their reaction to the data. For example, one person will find room temperature comfortable while another person will find it uncomfortable, though the temperature is constant. So that just shows that these types of scales have a lot of applicability for a designer. For example, knowing exactly how much their 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 product seems in a qualitative and uh, quantitative sense. So it's not just oh, it looks good, but it works good. It has a good weight. It has a good, you know, doesn't feel too hot. Doesn't feel too cold. So these forms of data can help, solve um, many of the issues. So next, I'm going to move on. Lastly, to human information processing systems, which can be represented flowchart as I put below. Uh, the arrows represent the flow of information through the system, where the boxes represent functional elements in the processing chain where information is processed. So here we have, for example, individual places, finger in hot water. So basically, you have it's kind of like a cause and effect. So we have an individual placing a finger in hot water. Next, the nerves in the finger detect high temperature, send a warning signal to the brain, where the brain processes the information and sends an impulse instruction to the arm, and the individual removes finger from hot water. And then after that, in between here, you could even put, subject feels pain. So you can apply um, this system to a common task. For example, how your product would be used in a specific situation. For example, uh, they have those saw stops. So it would be like the individual places finger in the saw. The system detects electrical conductivity. Um, Immediately, the system deploys a stopping mechanism that is stopping about, maybe 1,000 RPM of the saw, and then the individual removes finger and they're not hurt at all. So that's kind of explaining the application of the, the design, combining both quantitative and qualitative data to have a comprehensive idea of what is actually going on. So that's all I have for psychological data. I hope you enjoyed, and I'll see you next time.